Good morning, everyone. This is Bhargavi Kalyani from second year EC department from BVIT College. Today I am going to tell about sequential circuits. In sequential circuits, I am going to tell about flip-flops. Sequential circuits. They are known for or sequential circuits means the inputs it depends on our present and past inputs. Past input means here memory element. Sequential circuits also depend upon present output and past output also. Now let us talk about some differences between combinational and sequential circuit. Here are not much, but I will tell you a little more about this. Here in combinational circuit, it depends upon present input only. It does not depends upon past input. Whereas in sequential circuit, it depends upon present input and past output. And in sequential circuits, we need a memory element. And combinational circuits, we do not need a memory element. Combinational circuits are faster when compared to sequential circuits because it does not have any memory element. So it functions fast when compared to sequential circuit. In sequential circuit, there is a memory element which it need to verify the memory element to give the output. For example, in combinational circuits, there are adders, subtractors, multiplexers, decoders, and etc. Whereas in sequential circuits, we have counters, registers, flip-flops, and etc. Let us talk. The basic elements in sequential circuits are, like we discussed before, flip-flops, latches, registers, counters. Today I am going to tell about flip-flops. Flip-flops are a memory element which are used to store only one bit information. In flip-flops, there are four types. First one is SR flip-flop. It is also called as set and reset flip-flop. JK flip-flop, which is also called as Jack and kill base flip-flop. Whereas D flip-flop means data flip-flop and T flip-flop means toggle flip-flop. Now let us talk about SR flip-flop or set and reset flip-flop. Here S and R are the inputs and here we give another input called as clock pulse. And I forgot to discuss about another. There are two types in a sequential circuit. First one is a synchronous sequential circuit and second one is a asynchronous sequential circuit. Synchronous circuit means which follows a reference signal called as clock pulse. Asynchronous means which does not follow a reference signal like clock pulse. Now let us come back to SR flip-flop. SR flip-flop means it is a flip-flop built on set and reset inputs. Here we give R and S as inputs and a clock pulse as another input. Here which passes through AND gate and then through NOR gate. And we can see that the outputs are interconnected to the OR gates. Now, I am going to tell about the characteristic table. In characteristic table, there are four columns. One is present input, present state, next state, and state. Present input means the input which are we giving now, and the present state represents the QN, that means the output or present input qn. Now, and next state represents the next output by the given inputs R with R, S and Qn. Now let us see the table. R and S are zeros, then Qn is 0. Then the next state will be 0. And R, S are 0 and Qn value or the present state is 1, then the next state is also 1. This is called no change or memory state. Next, if R is 0 and S is 1 and present state is 0, then next state will be 1. R is 0 and S is 0 and present state is also 1, then Qn or the next state is also 1. Here if we have a next states to 1, then it is called as set. If R equals to 1 and S equals to 0 and Qn value is 0, then the value is 0. Next state value is 0. And next one, if R is 1 and S is 0, present state is 1, the next state is 0. This 0, 0 is called as reset. If both the inputs R and S are 1 and Qn present state is 0 or 1, the next state will be don't care and it is invalid. Now, let us talk about excitation table. Excitation table means changing present state means building a flip-flop from present state and next state. Here we have Qn equals to 0 and Qn plus 1 is 0. Then R is don't care and S value is 0. And next Qn value is 0 and Qn plus 1 is 1. Then R value is 0 and S value is 1. If Qn plus 1 is 0, then Qn is 1 and Qn plus 1 is 0, then R is 1 and S is 0. If Qn is equals to 1 and Qn plus 1 is equals to 1, then R equals to 0 and S equals to don't care. Now let us talk about JK flip-flop. JK flip-flop. It is also known as Jack and Kelby flip-flop. Here, let us talk about the characteristic table. Kj are zeros and Qn value is 0. Qn is 0 or 1. Qn value is equals to Qn. Qn plus 1 value is equals to Qn. If k value is 0 and j value is 1, Qn value is equals to 0 or 1 or 0 comma 1, then Qn value is equals to 1. It is called set and before 1 is called as no change. Now, if k value is 1 and j value is 0, Qn value is equals to 0 or 1, then Qn plus 1 value is 0. It is called as reset. If k value equals to 1 and j value equals to 1 and Qn value equals to 0 or 1, then Qn plus 1 is equals to 1 or 0, which is complement of Qn value. It is also called as toggle. Now let us talk about excitation table. Excitation table of JK flip-flop, which means building a JK flip-flop from present state and next state. If present state is 0 and next state is 0, k value is don't care and j value is 0. If present state is 0 and next state is 1, k value is don't care and j value is equals to 1. If Qn value is equals to 1, Qn value is equals to 1, Qn plus 1 value is equals to 0. Then K value equals to 1 and J value is don't care. If Qn is 1 and Qn plus 1 is 1, then K value is 0 and J value is don't care. Now, let us talk about the third flip-flop, D flip-flop. D flip-flop, it is also known as a data flip-flop. Here, the input is one flip-flop, that is data flip-flop, and we have two inputs from it. Those are D and D bar. D and D bar. Now, let us talk about the characteristic equations of D flip-flop. Here, the characteristic equations of D are D equals to 0 and present state is equals to 0. The next state is equals to 0. If D value is equals to 0 and present state is equals to 1, then Qn plus 1 is equals to 0. If Qn plus 1 are two zeros, then it is called as reset. D value is equal to 1 and Qn value is equals to 0, then Qn plus 1 value is equals to 1. If D value is equals to 1 and Qn value is equals to 1, then Qn plus 1 value is equals to 1. It is called as set. Let us talk about excitation table. Here, present state, we are building a D flip-flop from present state and next state. Here, Qn value is equals to 0 and Qn plus value is equals to 0. Then D flip-flop is equals to 0. If Qn value is equals to 0 and Qn plus 1 value is equals to 1, Qn value is equals to 1, then D flip-flop is equals to 1. If Qn value is equals to 1 and Qn plus 1 value is equals to 0, then D flip-flop is 0. If Qn value is equals to 1 and Qn plus 1 value is equals to 1, then D flip-flop is equals to 1. Here we can just remember a simple logic that if D flip-flop or D is equals to Qn plus 1, if D values are equals to Qn plus 1 or the next state values. Now let us talk about the last and final T flip-flop or toggle flip-flop. It has only one input, that is T equals to 1. Now let us talk about its characteristic equations. First, if T value is equals to 0 and if T value equals to 0 and Qn value is equals to 0, then Qn plus 1 value is equals to 0. It is called as no change. If T is equals to 0 and Qn is equals to 1, then Qn plus 1 is equals to 1. Then these two are called as no change states. If T equals to 1 and Qn value is equals to 0, then Qn plus 1 is 1. If T is equals to 1 and Qn is equals to 1 and Qn plus 1 is equals to 0, then this state is called toggle state. Here we can just remember a small, if the present state input and input T are different, then we will get the next state value as 1. If both are same values, then we'll have zeros. Now let us talk about excitation table. If we are building a T flip-flop from present state and next state. If present state is equals to 0 and next state is equals to 0, then T flip-flop is 0. If present state is 0 and next state is 1, we'll have t as 1. If we have qn is equals to 1 and qn plus 1 equals to 0, then t flip-flop is 1. If qn equals to 1 and qn plus 1 equals to 1, then t is equals to 0. It is same as before. There is a simple logic that if both present state and next state are same numbers or same binary numbers, then the t value is 0. If they are different in numbers, then it is 1. Now, let us talk about edge triggering and level triggering. Here, level triggering means the clock pulse and the levels it have. The bottom line or the bottom line or the bottom rectangle is called the lower or down level triggering, and the upper line is called up level triggering. Here, let us talk about edge triggering. In edge triggering, there are two types. One is positive edge triggering, another is negative edge triggering. The positive edge triggering means the clock pulse which increases is called the positive edge triggering. Negative edge triggering means the clock pulse decreases downwards with respect to time is called negative edge triggering. And applications of sequential circuits. We can see in daily lives such as in computers, in communication from one place to other place, and in control systems and memory units and etc. And sequential circuits hold state and provide controlled output transitions. Thank you.